Today we're going to talk about how lock picking works and what you're actually doing inside the lock. To understand that, you need to understand how locks work. So we're going to go over all the parts of a lock. This is the plug. It's the part that you stick your key in. It's the part you turn. It's a pretty important part. This is the keyway. It's in the plug. Also in the plug you have the pin chambers where the key pins and part of the driver pins rest. On the back you have the cam where you would put a tailpiece and it would actually actuate the lock and make the door unlock or lock. All of this here is the lock cylinder. It just, it's how you communicate with the lock. It's like a keyboard to a computer. The lock itself is the computer. This cylinder is what we pick. It's like a keyboard. In this plug here, you have construction key or construction chambers where you would, if someone was building a building, they would have a key that would work your lock. But then when you used your key, their key would cease to work. Now how that happens is there's between the key pins and the driver pins, there's little balls. And when the construction key is used, the balls are down in this chamber. When you use your key, it pushes the balls out of this chamber, and they fall down in here, and the construction key will never work again. So that you're not being robbed by the guy that built your building. That's pretty much the entire plug. You got the keyway, the pin chambers, the cam. That's all that's really important. Next we have the housing. Obviously the big hole here is for the plug. Slides in right like that. And that lines up those holes together. So there's pin chambers also in the housing. Pin chambers go all the way through. This area is called the Bible. Don't know why. But the pin chambers go from here all the way in here. It's the same chamber here as it is here. This cap here just goes on top to keep the springs from shooting out. And this little C-clip goes on to keep, when you pull your key out, you don't pull the whole plug and the pins with it. So that's important. Now the pins. They're equally important, and there's a difference in each pin. The spring, obviously just a spring. It pushes everything down into the key. If we look at a driver pin, come on, focus, come on. See how the edges are squared off? It's very square and sharp on the corners. I mean, it's a little rounded, but compared to a key pin that's very rounded on the top and bottom, turn around. See, both sides of the key pin are quite rounded. Some are pointed. A nicer lock will be flat on the top and rounded on the bottom, but this is a cheap lock, so it's rounded on both ends, so they don't have to worry about which way the key pin goes in. Some more high security locks will have chisel points on the bottom and it'll be flat on top, but that's the chisel points or the rounded parts, that's so that they ride over the humps and bumps in the key. If it was sharp like the edge here, it would jab into the key and it would work, but it would be less comfortable. Some locks it might not even work. It'd just be harder to use for sure though. Now let's look at what happens when you put your key in a lock. Inside the lock, the driver pin or the key pin touches the key, so it goes in first. Bink. Now see how it's sunk down in there? It's not actually doing anything. I can put this in and spin it all day long. But if I put a driver pin in here with it, it won't turn anymore. Now why is that? The driver pins stick out. So the driver pin's halfway in here and halfway into the plug, or the housing. Half in the plug, half in the housing. So when I try to turn it, I'm just smacking up into it. It's not actually turning. Now what happens when I put a key in? Well, if it doesn't fall off, let's try that again. with a straighter hand. Oh, I dropped it again. Anyway, see how it's flush with the top of the key, or with the top of the plug? That allows it to rotate. It'll still turn in here, but if I put the driver pin in, it won't turn. But if I put the key in, it'll raise that key pin to the top of the housing, and now the driver pin is lined up to the bottom of its chamber in the housing, and the key pin's raised to the top of the chamber in the plug, and they create a line that lines up with this line right here, and it rotates. If I take the key out, it no longer rotates. That's how locks work. Now there's 5 of these pin stacks, and they all line up with a proper key. That line between the key pin and the driver pin, that space right here, that's called the shear line. And that line between the plug and the housing up here is also a shear line. So when the shear lines of the pin stacks and the shear line of the plug and the housing all line up together, it'll rotate. I'll finish putting these pins in here. Now we're going to put the proper key in and see how it lines up all flush. That's the bottom half of the shear line right there, nice and round. Run your finger right over it, you don't have any humps. What happens if you put the wrong key in? See that one there lined up? But see, the other 2 are still down in there, which means the driver pin is also going to be down in there. These 2 here are sticking up higher, so they're actually in the Bible, up in the pin chambers that are in the housing. So they're now locking up the cylinder, as well as these 2 drivers. Now this one just happened to be correct, and it's doing its job right. But the whole key's not right, the whole lock isn't going to work. Now we can go ahead and put it in here. And prove that point. We'll use a proper key and an improper key. Now, how does the picking actually work? Why can I keep all 5 of those drivers above the shear line and all 5 of those key pins below the shear line? That's not as easy as it sounds. These 5 holes, they're made by machines, and nothing is perfect. So these 5 holes, you'd think that they all center line like so, but if I cut them in half like that, you can kind of see, maybe, how some of them might be off center. Some of them might be a little bigger than the others. Some of these are the same way. They might be a little off center. In fact, that's pretty bad off center if you measure the space between the edge here and the edge of the hole, and the same thing up here. You can tell there's a pretty big difference. I mean, it's small, but it's visual. You can actually see that. The differences in these holes are the reason we can pick a lock. If I apply tension to the plug, if I'm going to put 2 driver pins in, okay? There's 2 pins in this lock. If if I apply tension and I start raising these pins, I'm raising the first one and it's set, and I raise the second one, if I can get on it, and when I set the second one, the first one dropped down. Why did that happen? We'll go back and raise the first one. I keep slipping off. New idea. Let's put the springs back in the lock. Springs keep everything working properly. Without springs, it's a mush inside. And while you can pick them, it's just, you don't get as nice a feedback. You can still do it rather easily. Alright. Now, I'll apply tension. There's only 2 full pin stacks, so only 2 pins are locking this lock. I'm going to raise the first one, and it's not even setting now. Do you hear it fall back down? Well, not anymore. There. See it fall? Or hear it fall, rather? That's because it isn't binding. When I'm applying pressure, rotating pressure, it's not the pin that is locking this lock. But if I go to the second one, it's stiff. Oh, and it definitely clicked. Wow. These 2 pins are really low, by the way, so my shaft probably hit the first one. But in this lock, the second pin binds first. What if I add a third pin? Which pin do you think is going to bind first? The first, the second, or the third pin? Come on out of there. So I add a third driver, third spring, and we'll put the spring cap back on. I'll apply light tension and I'll start feeling again. The first one just falls back down. The second one, it's not stiff either. But that third one, it's stiff. And again, I hit the front 2 of my shaft because see how low they are. That's not the right key. See, they're really low, that other one's really high. The third pin set first that time. The second pin obviously set second because we already figured out that the second pin binds before the first pin. But I couldn't show you in that example because my shaft of my pick hit it. Anyway, let's go ahead and put this on so I don't accidentally pull it out the front. And we'll put another pin in. This is called progressive pinning, by the way. I need one more driver. I need one more spring. And the spring cap. Okay. Again, we apply light tension. We go in and we start feeling these pins. Which one is binding is going to be the give more resistance. I'm feeling nothing. Let's go back. That one was stiff, but I don't know if I was able to set it or if it'll fall back down. I'm going back all the way. This fourth one that I put in is very stiff. Now the third one's very stiff. If you try to set a pin that isn't really binding, you're not going to feel that set. You might overset it, which is where you push the driver pin or the key pin up into the plug. And that's obviously not going to work for you. When you have that problem, you just release your tension, start over. We're going in looking for a stiff pin. That fourth one's set. Try not to overset these front two because they're so low. There it is. The problem with low front pins is as I slide my pick in, my pick shaft raises higher and higher and higher the deeper I go in. If you notice how it's on a slope, and it will raise those front pins too high accidentally. So if your tension wrench is in the bottom like mine is, that puts my pick up above that first ward, which is actually on this side. So if my pick is above the first ward and I'm trying to pry and lever on things, see how I'm hitting that shaft, that bottom pin there, the bottom space? It can get to be a pain when you're trying to pick the back one and it's high and your pick shaft is hitting the bottom. So that's why I was having such a hard time showing you binding order. But anyway, hopefully you understand it. It's pretty simple. You feel inside the lock for a stiff pin. That's the binding pin. You raise that pin till it sets, which you'll feel and hear a click. And you'll even see the plug move a little bit every time. And then after that, you move on to the next one. You check every single pin. There's 5 pins, check them. Which one's the stiffest? Set that one. Check the remaining 4. Which one's the stiffest? Set that one. Check the remaining 3. And so on and so forth. It's like clockwork every time. That's a low security cylinder, and that's how lock picking works. This tool's provided by Cliff Lock Picks, by the way. It's a rubber coated handle, red. Just thought I'd throw that out there. I debuted them in my last video. They're very nice picks, about $9 a piece. I think the rubber coating's an extra $1, so it's $10 pick. Expensive, but really good quality. And that's the video. Thanks for watching.